So we're going to be solving exponential equations today, and here's what the steps will look like. Just like we did with the logarithm yesterday, we're going to do whatever we can to get the exponential term isolated. Then we're going to take the logarithm. Now, I'm going to always take the natural logarithm. You can take any logarithm you want. I'm going to always take the natural log. We'll do that on both sides, which will allow us to bring that exponent down. And once we've completed those three steps, what's left will be algebra 1. So the first couple examples here will be pretty simple. They'll look like the things you did in algebra 2. And then the last couple of examples will take that concept of solving an exponential equation and we'll amp up the difficulty level just a little bit so that you're not just repeating algebra 2 here as a class. So isolate the term with the exponent, bring in the logarithm that gets the exponent down, then do a bunch of algebra to get the variable alone. So here's an example of an equation that was created by one of the story prophets in our book. And if the goal here is to solve for x, what's the first thing we're going to do? Divide by 1,000. We're going to try to isolate this the exponential term. So 1.055 raised to the 4x is going to equal 5. Now that I've isolated that, I can bring in a logarithm. I can bring in any logarithm I want. I choose the natural log. Because I have a logarithm with an exponent inside of it, that exponent can move to the front. Now, if I want to get this x by itself, I've got to do two things. First, I need to divide both sides by 4. Next, I need to divide both sides by this mysterious number, the natural log of 1.055. This is the value I was looking for. And you can just leave it like that. There's no need to enter that into the calculator. You certainly may, but it isn't a necessary part of the process. This is the exact value. If you punch that into your calculator, you're going to get a long decimal. If you're set on float 9, it's going to have 9 decimal places. Of course, you're going to want to write it down to the nearest 1,000. But I'll almost always ask you to find the exact values in these problems. Just saves you some headaches, to tell you the truth. How do we solve this? And what would you do?
I don't even know.
I'm trying to get x by itself, and that x is an exponent. There's only one way to get it down. Antonio, bring in a natural log. Take the natural log on the left. I can do that as long as I do the same thing on the right. And the reason I did that is because now I can take this variable and set it over here. By the way, what is the natural log of e? 1. So that makes this the answer. That's 1. I don't need it. You're trying to solve for a variable, and that variable is the exponent. You're going to need a logarithm. What's the first thing to do here? Divide by 3. That leaves me with 2 to the x is equal to 14. Now what? Insert a natural log. Natural log here, natural log here. This becomes x times the natural log of 2 is equal to the natural log of 14. What's the last thing to do? Divide. Natural log 14 over natural log 2. Now that does not equal the natural log of 7. Now, do not distribute that natural log to the whole thing and then say, oh, now it's 14 over 2, so I can call it 7. No. A minute ago I mentioned you can bring any logarithm you want into this equation. Let's see how this looks if I decide to bring log base 2 in its place. 2 to the x is 14. If I bring in log base 2, this becomes x times log base 2 of 2 equals log base 2 of 14. What number is this? 1. That yields the answer, log base 2 of 14. If you apply the change of base rule here, isn't that where you go? You can bring any logarithm you wanted. And I'm fairly confident if I went and I looked in your Algebra 2 book, they taught you to bring in the logarithm to match this base. Feel free to do that. I don't care. I prefer the natural logarithm for 2 reasons. Number 1, I'm a calculus teacher, and in calculus, we always use the natural log. Number 2, that log base button was only recently added to your calculus calculator. So in the past, if you wanted to actually find this number, you know what you had to do to it? Use the change base, meaning you ended up here anyway. So if we were going to end up with a natural log answer, why not just start there first? So like I said, I always go with a natural log, but you can go with any logarithm you want. If you're having a tough time deciding, go with natural log. If you don't like that, use the logarithm to match the base in the exponential. What's the first thing you would do right here? Divide by 4. We want to isolate that term as much as possible before bringing in the logarithm. First thing I'd do here, add 4 and then divide by 2. Okay. Now it starts to get a little bit more challenging. We've got a couple of exponentials floating around here. There's no way I'm going to isolate these. Does this look like anything else you've studied? How many terms are out there? It's a trinomial. You spent a lot of time studying trinomials. And how did you solve trinomial equations? Factor. Now, all of the trinomials you've factored in the past basically had a perfect square as the first term. So is this one. It's just a little harder to spot. That's a perfect square. It's e to the x quantity squared. Minus 3 times e to the x plus 2. And I want to know, where does that equal 0? Well, to get that e to the x quantity squared, I must have had a pair of e to the x's. And where did this plus 2 come from? Plus 2 minus 1. Very good. Now, the product of 2 quantities is 0. What does that tell us? One of them is 0. So this converts to e to the x minus 2 equals 0, or e to the x minus 1 is equal to 0. So e to the x has to be 2, or e to the x has to equal 1. Now I'm at the point where I can solve this thing using logarithms. Natural log here, put 1 here. This becomes x is the natural log of 2, or log here, natural log here. X is the natural log of 1, commonly referred to as 0. So it had 3 terms. It's a trinomial. A little harder to recognize, but this thing is a perfect square. Now watch this. This is even worse. I have to do some real juggling to make this one work. But it's another of these trinomials. But in the previous problem, at least it was something squared and then the same quantity not squared. This is a little different. What's that? Minus 3 squared. That 9 to the x is really 3 squared to the x, or 3 to the 2x. And isn't 3 to the 2x the same as 3 to the x squared? See if this works. So that 9 to the x really turns out to be 3 to the x quantity squared. So this first term actually is a perfect square. So if this is 3 to the x squared minus 3 to the x minus 6, let's just make this look a little more familiar by taking all of the 3 to the x's and rewriting them as the letter u. Becomes u squared minus u minus 6. I bet you can factor that. What do you get, Eric? John?
U plus, or minus 3, and then u minus 2 plus 2.
Yep. Now I'm trying to solve this thing for x. So I end up with u is 3 or u is 2. And remember, u was simply 3x. So it works out as 3 to the x equals 3, or 3 to the x is negative 2. How do I solve that? How do I solve that? Insert a natural log, and we'll end up with x is the natural log of 3 over 3. Natural log of 3 over 9. Yeah. Gosh, I'm embarrassed by that. Why did they cross this one out? You can't take 3, raise it to a power, and have it turn out to be a negative. Okay, one more example. We'll finish this lecture. We'll finish this week and give you a few problems to try over the weekend. This is one of those problems that you've never been trained to do specifically. There are no steps that are going to be taken here that you haven't done in the past. It's nice to note that the exponentials are already isolated. I will be done with this problem when it says x equals. What do you want to do?
Natural log in there, see what happens.
Throw a natural log in there and see what happens. Make sure you throw it in on both sides. What does that do for us? Brings the exponents down. In parentheses, I might go. We're getting closer. Now, the natural log of 2 is a number. Precisely, it's about 0.693. If this said 6, I think you'd know what to do. If that was an 8, I think you'd know what to do. Say again? It would distribute. That's exactly what I need to do. Distribute that natural log of 2, distribute the natural log of 5. Now my goal here is to get x alone. Can I get x alone if there are x's on both sides of this equation? You can? Tell me how. What would you like to do next, Allison? Put them on the same side. So let's move this to the left and this to the right. Now I've got all of the x's moved. What would you do next? Say that again. Let's factor out that x. That gives me x times the natural. What's in there? X times the natural log of 2 minus 2 ln 5 equals quantity on the right. You're one step away from being done with this problem. What is that step, Sam? Division. Divide both sides by this quantity, and here is your value. So all that was a bunch of distributing, adding, subtracting, and dividing. There was nothing new there. It's just that you were doing it with numbers that weren't the most friendly looking numbers. It doesn't get any harder than that. So let's have you do a little practice. I'm going to skip these story problems because next week is all story problems. We don't need to do anything.